బాలకృష్ణ సార్ రికార్డింగ్ ఇప్పుడే చేయకండి, కొంచెం ఆగండి.
అది పాజ్ చేయండి సార్, మీకు హోస్ట్ ఇచ్చాను, పాజ్ చేయండి. రికార్డ్ క్లిక్ చేస్తే పాజ్ అయిపోతుంది.
Then the second one is on the novel algorithms for the swallowing detection during sleep as well as the normal period. So I'm going to talk about that as a second part of my research. And the third part of research is based on the smart sensors and remote monitoring, which I worked at Western Sydney University on a multi-million-dollar CRC project. That's a sleep project where I developed lots of algorithms to detect the sleep and cardio parameters using the T-shirt. And and finally, I'm going to talk about a bit on digital health and precision medicine, which is very important in modern days. So where I'm going to talk briefly on the personalized sleep solutions for individuals, where I developed this unique sleep diary, which provides the the qualitative analysis of the sleep. So yeah, with that, I'm going to talk about these topics one by one, and I'm happy to take any questions in between if you want, or otherwise, I can keep the questions at the end. So before I proceed further with all those explanations, it's better to explain the audience some of the key parameters there. So the first one is the respiratory rate, because I'll be using these terms many times. So therefore, it is important for me to explain what are these parameters. So the respiratory rate, because all the sleep studies we use the term respiratory rate. So that is the number of breaths a person takes per minute. So typically a healthy person takes around 12 to 13 breaths per minute. So this is different from our heart rate. So this is number of breaths per minute. So then the heart rate is number of heartbeats that a person per minute. So that is it's per unit of time. So that's called beats per minute. And then the variability in the heart rate itself. So because that we call it as a term HRV. So HRV is basically very important for many physiological and health assessing health, including the diabetes and other things. So heart rate variability means basically it is measured in both time domain and frequency domain. So it is basically how the heart rate changes, per minute or per second. So the variability in the heart rate is called as HRV. Then the sleep apnea, which is basically serious sleep disorder in which our breathing as repeatedly stops and starts. So that is the term used as a sleep apnea. So then that is measured as a term AHI, that is the apnea hypopnea index. So then finally the body position. So where in sleep and other parameters we use the body position, that is the position of the body at one point in time. So I just wanted to explain these parameters before I proceed with the the actual research explanation. So first I would like to give a brief introduction on the under the mattress sleep tracker, because these are very common these days, because you have seen many sleep related, like the traditionally sleep related studies are done using the polysomnography in sleep labs. But now because of the technological advancement, we see even the smart watches where we can detect the sleep. And also under the mattress sleep tracker is very common one. So under the mattress sleep tracker, as you can see in this figure, basically it goes under the mattress, and then it uses the ballistography technology. That means, the based on the pressure movement, and then during our breathe in and breathe out, then the based on the pressure movement, it creates the signal. So those respiratory signals are used as a mean parameter to detect sleep and other things. So why I'm telling this is basically, we have a collaboration with a French company called Withings. They developed this under the mattress sensor, and we are developing some algorithms for them, and also they have shared lots of people's data all over the world for us to analyze. So this is what the data we got from Withings. So over 12 million nights of sleep data. That means, it's a very large data set. It's a huge data set. And you can see that how the sleep tracker looks like. It just can go under the mattress. It's a very thin foldable tracker. It is developed by the company Withings in France, and then they shared this data with us. And then we used some kind of a criteria, because that was a very big data. So we used several criteria before using those data. So the first criteria was, we did not want to do any analysis with the single night sleep study or something. So that means minimum 20 days, 8 days of recordings for each participant. So that means the first criteria was to at least a single person's data. If you are considering, then that person should have at least 28 days of data. So that was important for us to assess the variation in the night sleep every night. So then also we use the blood pressure data. So because that is for to define the hypertension. So that is basically blood pressure measurements. Also, we collected minimum 3 blood pressure measurements. And also the blood pressure measurements as taken, those data were taken twice. One is the baseline data, that means initially 3 nights of 3 times data, and then the follow-up data. So that means again, it is again 3 times
అంటే
data.
మనం
So
ఏం కాదు లైట్
that is
అనుకుంటే
the
ఫీల్ కోసం
standard,
వచ్చింది
the blood pressure assessment used in, the worldwide research. So that's what we followed those guidelines, because and also it was a very large data set. So the first research we identified, basically, because this data was a very huge data, and then it was from all over the world. So we wanted to test, or our hypothesis are basically, are adults sleeping enough? That means, is because according to the World Sleep Organization, the every adult should sleep minimum 7 hours per night. That is the healthy adult. But again, in some countries it is taken, especially in Western countries, it is taken very, sleep is has taken very seriously. But in developing countries and other places, the people usually ignore the sleep importance of sleep. So 7 hours of sleep is the minimum recommendation. So that's the American Sleep Association. They are the worldwide body. And then we wanted to check, because we had the last data set, and after filtering the data, so we had around still around the 66,000 participants, with each participant had, like I mentioned, minimum 28 days of sleep. So that means basically we had around nearly 12 million nights of sleep data. We are from 64,000 participants. That was a huge data. So then we, for our sleep study, we classified, or we categorized this, as you can see in this figure, we categorized them as the different groups: young adults, and that means 18 to 25, and then the normal adults as the 26 to 40, and then the adults as 41 to 50, and again adults again as 51 to 65, and then the older adults are basically classified as 65 and above. So these are the ones, and then you can see that there is a based on the sleep, you can see in this graph, where only 14.2% of the young adults slept less than 7 hours. And then you see that that percentage increase in the adults group. So then 7 to 9 hours was this graph here, and then the greater than 9 hours only. You see that greater than 9 hours only percentage is very less. So that means it's yeah, around 4%, 3%, and so on. So that means people, basically we found that sleep deprivation, that means people sleeping less, is very common all over the world, and that is especially the young and the normal adults sleeping less. And then the adverse effect of sleeping less, that basically it causes the insomnia, and then also if you're tired, when you're driving and all, it may cause the accidents and so on. So therefore, yeah, it's a bigger issue. Based on this research, we found that basically, we see that here also in the next graph, only 30% of the adults sleep less than 7 to 9 hours per night. So that is based on the 12 millions of nights of around 66,000 people. And then we also found that females had longer sleep than the males. So that is based on this data. So therefore, our study, that was an important study, showed that there is an effort needed to support people to have the optimal sleep. That means people need to sleep at least 7 hours minimum per night to maintain a healthy lifestyle. So that was our first hypothesis, and it was published in Sleep Health with impact factor of 4.1. So the next next one I'm going to talk about is basically obstructive sleep apnea. So that means sleep apnea is again, like I mentioned, it is the basically it's happening because of the blockage of the airway, and it is considered as a, if you it is measured using the term called apnea hypopnea index, which is basically it is measured per hour event. For example, if someone don't have a sleep apnea, means if these events happens, in a simple term, if these events happens less than 5 events per hour, so then that means people don't have a sleep problem. And if it happens between 5 to 15 times in an hour, so that means basically that's how the it's a blockage of airway. It happens only for 10 seconds or more. That's how the event is calculated. So if it happens between 5 to 15, then it is a mild. 15 to 30 is considered as a moderate, and then some people with greater than or equal to 30 events. So that it's considered as a severe sleep apnea, and also it causes lots of snoring and other events. So how it is measured in clinics is basically people have to undergo an overnight sleep study, one night sleep study, and which is very expensive, especially in Western countries. It costs a lot because it uses several sensors, EEG, and then the EMG, and then the chest strap, and so on. So that means it's very expensive, each study. And the one important thing is they only measure it using just or the doctors assess it based on just one night sleep sleep data only. But the one night sleep data itself is a dangerous one, because it will not tell clearly the the variability in the sleep. So that's what in that case, the sleep trackers, like whether you consider as a wearables or the under the mattress sleep tracker, that means it's less expensive, because you can put it under the mattress sensor under the mattress, and then you can monitor the people for many days. So that's how we did here. So
We can say Ramkumar sir ki village anta.
we wanted to see the impact of night-to-night variability. Because like I mentioned, if you just take one night sleep data, you can't just measure the night-to-night variability. But if you take more than one night, then you can measure the night-to-night variability. So that's what we wanted to measure, the impact of night-to-night variability in the obstructive sleep apnea. Okay, so in that again, there were around 68,000 people aged between 18 to 90. We used those data. And in these cases, per participant, you can see that per participant, minimum night was 170 night per participant. So then you can see that if you multiply 170 with 67,000, that then it basically comes to around 12 million nights of sleep data. So again, it was a very huge data. Basically, we found that if you just use one night sleep, then you can see that it's basically false positive. Then and also the ROC curve shows that one night data, that only gives the accuracy of around 80%. So that means basically, in that case, 20% may be misclassified. So that means one night sleep data, if you just consider, then it is not good enough. But then what we did was we assessed we increased the number of nights, like the sleep data, like 2 nights, what happens, 7 nights, what happens. Then we found that if you use the 14 nights of sleep data for a participant, then basically it gives the very good accurate results. So also it provides the clinicians or the doctors to assess the patient clearly whether they have a severe sleep apnea or the how much the variation is there in their sleep and so on. So this was published in American Journal of Critical Care Medicine, and yeah, the impact factor of around 30. So that was the this study demonstrated that traditionally used single night sleep study is not good enough. So that means the doctors need to consider more than at least more than 7 nights of sleep study to assess that. But the problem with the clinical sleep studies, if they do it for a single person 7 nights, cost is very huge. So therefore, the solution is either using the wearables or the under the mattress sleep tracker. So that means you can give those things to patients and then take it at home, and then they can basically their data can be collected. So this can be the future solution in this area. So the another study we did was basically to see, that's what I mentioned about the blood pressure. So we wanted to see whether the sleep irregularity, that means the variations in the sleep, whether is it related to hypertension. So hypertension is nothing but it's again the term used to measure the high blood pressure. So the hypertension is not good. If you might have heard about that also. If you go to the doctor and all, then they measure your systolic and diastolic blood pressure. If it is 140 mmHg or higher as a systolic, and diastolic, if it is 90 mmHg or higher, then it is called as hypertension. So which is not good for especially the older people and all, because it is it's common in diabetes and other people and patients. And yeah, so it is again another issue. We wanted to see whether variation in sleep, whether it is associated with the hypertension, or that means whether it can cause the hypertension. So because we had a large number of data here, around 12,000 participants. So our study support that sleep irregularity. That means sleep irregularity means one night sleep to another night sleep. The variations in night sleep, because we used minimum 28 days of data. So this was good enough for us to see how much variation was there. So then we found that this variation in sleep affects it is directly related to hypertension, or it causes the hypertension. So variations in sleep in a simple way, if I put it, it's like, one night you may be sleeping 12 hours, then next night maybe only 4 hours, then next maybe 5 hours, next maybe 8 hours, and so on. That is the irregular sleep. So if you do that one, and then then it basically is directly related to the hypertension. So that's for the study, the proved, and it was again published in high impact factor journal hypertension. So then also quickly I go through this one. So again, we want to check whether high night to night variability in obstructive sleep apnea, how it is related to hypertension. Again, the study proved that even if you have the high night to night variability, it's even causes the uncontrolled hypertension. So this is again published in Nature Digital Medicine. Okay. So this is about the sleep related study, the big data I wanted to talk about. So the next one, I'm going to talk about the AI applications and the signal processing. The first one is the sleep report extractor. The sleep report extractor in a normal sleep study in the clinics, if they use several sensors and several parameters. So usually typically when they do the sleep study, so they collect including the age, health, the gender and all those things, BMI and all those things. If they cover, they calculate around 400 plus parameters. So these parameters again, what they do in the normal sleep clinics is they generate a sleep report. But those sleep report, again, it's okay if you want to just extract a vital parameter. For example, this it creates a sleep report of around, as you can see in this figure, it creates around 400 plus. And then, but the doctors are interested. If the doctors are interested only in heart rate related parameters or the respiratory related parameters, then they have to just go through the entire sleep report and then note down and all. So this is still okay if you take one patient. But what about if you are doing a clinical study with thousands of patients? Then how do you get the this respiratory data or the heart rate related data or the EMG related data? So in that case, people have to just sit down and then just take out those data, put in the Excel, and then do all those things. So again, that is a tedious task, and also human error can occur while copy paste kind of things. And again, this is not good if you are doing the clinical studies. So this sleep, if you are wondering how this sleep data or report is generated, so it is generated by the basically it's generated by the the polysomnography equipment we use. We use either from Compumedics or other big companies, or Philips or these companies. If you buy those devices from them, then that device comes up with all the sensors and then also softwares which can generate these sleep reports. But what they don't do is they just generate the sleep report for an individual, but they don't do there is no provision there to get the certain parameter calculation. So in our when I was working at Sleep Lab, then we had this issue, and clinicians they often during the meeting and all, they were saying that, okay, look, this is the problem, we are doing these clinical studies, we need certain times we only need some data from each participant, and also to comparison and all, it's basically a tedious task. Then then I said, okay, I may be able to come up with some solution. So that's how it started. So therefore, what I did was basically I generated a MATLAB based app, and later we converted it into Python app. So that app basically what it does is basically it's the PSD report extractor. So that means I initially I used the template. Basically, I checked how many parameters are there. So then I created a basic template, and then when each report is generated, I extracted each parameters from each sleep report to match that template. So it was a kind of a template matching technique. Some AI was used for the classification kind of things. So I'm not going in detail on that. Basically, in that, using that, basically we were able to generate. So you can see here, like each event, these are the patient name, when this software was run. So basically it creates, say for example, if there are 20 patients or 30 patients, then their file name, then name of the patient, study, date of birth, and everything it reports. So that means, everything will be extracted from that report, and it creates an Excel file. Once it creates an Excel file, it can be directly used for statistical analysis or any comparative analysis and so on. So this made the life easier for the this kind of technique made the life easier for the clinicians. So as you can see, this is a stereotypical sleep report there. So there is a video there. So I can just run through this video. So this is this is how the sleep report looks like. It's a not lengthy video, so you can see that there's a sleep report, that's how the standard sleep report looks like. This is per patient. So you see how many parameters it collects, and the oximetry data, body position, so many things. And if the clinicians want simple information, it's very hard to extract that. So even this is just a typical one simple report. So from this report, basically, see, then I loaded that data into the in a folder, and then there's a template I load, and then basically it process the template file. So then what it does is basically once the template is loaded, then you just load the entire file, so that it reads each file name, and then so you can just, now it's ready to extract them. So that's how it extract. In this case, for demonstration, see, it's very quick as well. So you can see that it's extracting now. It's around 40. For around 40 patients data. Those sleep report is extracted. Then you can see that those 40 patients data, you can see it's extracted to a simple Excel file. And if I browse through that vertically, then you can see that there are around 400 plus data it is extracted. So this was very useful for the clinicians. Now if they are doing especially they're doing the trials with thousands of participants, and for them it is now very easy process to look at just everything in one place in a simple Excel file. Okay. So so that was the one very important the AI method which I used for the sleep extraction those process. So the next one, I quickly go through the AI again. The signal processing. This is mainly with the signal processing. The swallowing. The swallowing again, that the swallowing is a major problem in many cases, especially if the people have a dysphagia and all, then they can't speak and all. So the swallowing again, we in the night, people swallow as well. So that is called as a reflexive swallowing. When that happens, sometimes the people get up in the night, because they can't swallow everything fully. So that's also not good for health. So therefore, we developed this software called automatic swallowing detection. So that is based on the top panel is on the it's basically a flow sensor, epiglottic pressure. Epiglottic means basically it is the sensor placed in the throat. That is the epiglottic pressure sensor. Then second, the bottom is the flow. Flow is the normal airflow sensor, which is basically coming as a nasal cannula. Okay, so we collected these two data. Then I developed the algorithms. Basically, the swallowing, I developed this precise algorithm. Whenever the swallowing happens, the epiglottic pressure, the signal goes up. That means, there is a spike in epiglottic. And then at the same time, the pressure signal was coming as a flat. So that's how the normal clinicians way, or the doctors, they told me like this. Okay, they told me that, look, when we have these two data, but we don't have the automatic solution. That means, we can say that, okay, whenever there is a swallowing happens, the epiglottic pressure, there is a spike, but then there is at the same time, the pressure signal becomes flat. But again, then they told me that pressure signal becomes flat means it could be due to artifacts also. So therefore, if you want to develop a method, that means you need to use a sophisticated signal processing method to do that. So therefore, basically, I used those. The first thing what I did was I from these two sensors data, I use the signal processing methods to basically get the breathing cycles. So that means the breathing cycles mean the inhale and exhale kind of signal. So their breathing cycle, then you can see here on the left side. So those are the colors are different breathing cycles. Then the spike is the one in the green is the spike where that is the epiglottic where the swallowing happening. And then and at the same time, you can see that the middle one is the flow sensors. So then that becomes flat. But again, like I mentioned, the flow can become flat even with the artifact also. Therefore, I had to use a sophisticated signal processing method to identify the artifact or eliminate the artifact first. So then using this method, was able to detect the swallowing very accurately. So then, recently we tested this on the large number of sleep patients, who were sleeping minimum 7 hours like that. And so there is again the video. I won't be playing that because of the time. I know the time this one. So I'll just skip this video on the that. So again, the swallowing, we also to do the swallowing testing for the during sleep. We basically there is a standard method. You might have heard about the CPAP. CPAP is the mainly used, developed by Resmaid or Philips and all. Many patients who has a severe sleep apnea, they use that mask and then sleep. But again, that is very inconvenient during the sleep. Okay, it solves the sleep problem, but again, it is inconvenient during the sleep. So therefore, one of the way it can be eliminated is using the other methods like the using the they use some kind of a spray these days, or to clear the upper airway, or some kind of yeah, there are other measures are there as well. So basically we tested this swallowing because we wanted to test this effect of the swallowing when people are using this CPAP, because in our sleep lab when they came for studies, we wanted to test the effect of CPAP, and half of the night the patients were using the CPAP, and half of the night, other half, they were not using the CPAP, because we were doing this study to find the effect of CPAP. So during that time, I wanted to test the effect of swallowing during the the CPAP, like when the patients use CPAP, whether they swallow more or less. So that's what the hypothesis. So then basically we also wanted to test this one with the different sleep stages as well. So that means I hope some of you may be already knowing about the different sleep stages, S1, S2, S3, then the wake and REM. These are the different sleep stages we go through every night. So then basically our the study showed that basically if they the night swallowing basically increase the OSA severity. So that means the first thing we found out was basically if a person has a more sleep apnea, So then basically they swallow more. So that's how this study revealed. Then also, if they use the CPAP, they use the mask, basically we showed that their swallowing frequency reduced. So that means, if the people have a severe sleep apnea, that means they swallow more. So then how can you reduce that one? So you can do that one by using the CPAP, that means using the mask. But downside of using the mask is that it basically causes lots of discomfort to the patients when they're wearing the mask. So this is the software developed. It's automatic swallowing detection using airflow and epiglottic pressure. So currently this is tested in the Sydney University. There's a big swallowing lab, and they are testing this one. So and then we're trying to commercialize this one in swallowing clinics and other places. Yeah, so that's the second application. Now I quickly go through the smart sensors and remote monitoring for sleep apnea again, and also the cardiovascular diseases. So here again, this shirt was developed by Western Sydney University researchers, and as you can see here, the sensors were embedded inside the shirt. Then basically they were just the resistive bands. So that means, during the breathe in and breathe out, you could basically get the classic, the sinusoidal kind of signals. Then using those signals, one sits on the upper chest, one on the lower, and then one on the abdomen. So then basically that could give you the respiration as well as the heart related parameters. So that's, yeah. So again, the first thing was because when we developed these ones, the first thing was, we wanted to look at the ground truth, because that was the unique kind of signal, and then we wanted to see how much artifact is there, or what is the best signal we can use it for the the algorithm, the sleep apnea detection or the heart rate detection and all those things, because we were not using the ECG, or we are not using any respiratory sensors or something. It was just a t-shirt which was embedded with these several sensors. So therefore the first thing was basically to identify the artifact and remove those ones, and then those marking the artifact, and then once the artifact is identified, then they store remove the identified the artifact remote data for further analysis. So therefore I developed this software, again, artifact removal. So basically, which was again, using the very simple method could remove like you see here, using manually, we used manually to detect the artifacts. So you can see that one, as I click on those artifact signal, then basically those two signals becomes equal, because one was coming as from the polysomnography sensor as a ground benchmark gold standard, then another one was from our t-shirt. So that means basically the top one was from our t-shirt, and then the bottom was coming from the gold standard polysomnography. So that means, we had to match those two signals to get the accurate results. So therefore, this ground truth toolbox was developed to do this artifact elimination, to get the clean signal first and then use it for the other purpose. Again, yeah, so then first study was to do the respiratory rate analysis, then artifact removed. Then you can see that with the artifact, then the respiration, this part of the signal, there is no respiration at all. But when you do the ground truth, then you can see that you can get the clear respiration signal. So then we did some study using the different algorithms. Then we can see that when we were not using the respiration rate, the respirations were very high, because with the artifacts and all those things. But when we use the ground truth, the algorithm, basically it matches the ground truth of a flow, means it is polysomnography data, that's the gold standard. And then that is with this is coming from the electroresistive band, that is coming from the t-shirt. So this was very important for the algorithmic development for the study as well. So then also the second thing was to extract the heart rate from from just the those respiration bands. So again, that was the challenging. So we compared that again. We used this ECG as a ground truth, but again, the challenge was basically to extract the ECG from this chest pulse. So basically, then you can see that this is standard ECG. And then these were the peaks here. You can see that those were the data extracted as a ECG equivalent. So we got around 95% accuracy compared to the standard ECG using our own sensors. So then again, quickly, yeah, so we also developed using that sensors alone to detect the sleep apnea, like, using the moving window and in the AI, and also I developed an algorithms called auto gain, so which basically makes the two signals equal. And also, I'm not going in detail on that, but yeah, using that again, we developed this algorithm to detect the sleep apnea. And also currently the t-shirt, the miniature version of that, a company in Sydney, they are testing this one and for commercial use and all those things. Okay. So then also body position, we also use the accelerometer to see how people sleep, what position they sleep, whether they sleep supine or they sleep in the right position or the left position or face down kind of things, because this was very important. And again, since the accelerometer was embedded, so then again, we developed the algorithms based on the accelerometer to detect the body position. So in reality, in overnight sleep study, EMG is mainly used to detect the body position. So, but that can be easily replaced by accelerometer, which is very less, it's less expensive, and also it is easy to use. And now you can see that smartphones have the accelerometer and all, even that can be used as well for these kind of studies. So finally, I'm going to talk about the precision sleep medicine, because sleep, again, one way of detecting the sleep is or using the overnight sleep study or the under the mattress sleep tracker and all. But again, these days, even the clinicians, they also collect the qualitative data. Qualitative data means a sleep diary. A diary will be given to mainly they use the paper-based diary. So that means they ask the patients to write about how their sleep was, what time they went to bed, and then when they turn off light, and then whether they wake up in the night or how many times they wake up, and based on that you can easily calculate the sleep efficiency, because that is that one, if the clinicians collect that personalized data, then they will assess person's sleep quality, and then they see whether they need to undergo a further test or not. So that is usually very common these days, the sleep diary. And you can even get there are many sleep non-commercial, clinical sleep diaries you can get as apps also these days in iOS, and then both these devices as well. But this sleep diary, I developed this sleep diary using the R Shiny app, because which can be run as a freely using the R server, and then with the Google Sheet, you can basically run pretty much everything for free, because Google Sheet you can use, and then you can connect that one with the R Shiny app, and then you can run this one with their free server. But if you want to do it as a commercial use, then maybe you have to run it on your own server or so on. So this is what the sleep diary I developed. So basically that is with the help of clinician. So it was asking several questions like, what time did you go to bed? And then what time did you turn off the light? And then after turning off the light. So yeah, so these were the kind of typical questions. But one of the things problem with the traditional sleep diary. So that means people sometimes will be very reluctant or lazy. They may be putting the wrong information. That means they may say that, okay, I went to bed at 10 o'clock, but my light was turned off at 8 o'clock, kind of things, because that was all the false reading it gives. But I avoided that one here. Basically, if someone says that, okay, they went to bed, this one, that means that time is locked. That means even the next question, once they add that information, next question will basically, when they ask the next question will start from that time what they entered. So that means they really can't go back and enter false information and all. And also I provided them the provision. So that means if they, whether they, how many times they wake up in the night and all, to get the precise information for the clinicians. So that way, whole time can be added at the end. So then, yeah, what time was the final awake, what time finally they get in, out of the bed. And before that, did they get, sometimes again, wake up to drink water or go to bathroom. So I provided those. Then again, when they did that one, then there was a provision for them to submit the sleep diary result, and then it basically saved into Google Sheet and so on. Okay, so again, there was that diary could basically calculate the sleep time. You can see here total time in bed, sleep efficiency, and so on. So again, it could give the weekly sleep for a person, when they enter this sleep diary information, it could give them the weekly sleep data or the monthly sleep data, depending upon the, it is very good for the clinical studies and also some kind of automatically, giving the report as a, the plots with everyday sleep details and all. So again, sleep efficiency, and also finally, some kind of a flow chart kind of things, when that patients could see also their weekly details and also and finally, yeah, there was I made a provision for them to download a report as a PDF. So that means basically this is keeping in mind that, like in future, if you make it everything is a wireless based one, that means, this can be sent to cloud, and then from there basically the go to the doctor, and then doctor can basically directly download the report in the clinic and assess, so on. So again, yeah, some demo, yeah, I skipped this one. So yeah, so yeah, that basically, yeah, I run through the demo and that's fine. So yeah, in conclusion, yeah, so there is opportunities in biomedical space everywhere, because I can see that nowadays in India also there are lots of emerging companies in biomedical space happening, and especially with the mobile based devices, there are so many solutions are there in terms of remote health monitoring. You can see that that one is very, very important, especially in the India, where we have the many remote places, and those places basically these kind of devices or these kind of mobile solutions can be really helpful for the patients, because the otherwise they have to travel for a long time. That's the first thing. Second thing is cost is more if they admitted to bigger hospitals and all. So yeah, I can see that a lot of those innovations happening in India also, and yeah, so it's a good thing to see. And world, yeah, I think in the future, because of the advancement in mobile technology and smart sensors and remote health monitoring, will be very common in future. But there are challenges as well. You can see that AI is there everywhere, artificial intelligence, and then again the AI is, there is a good and bad things with AI. So the AI can do lots of misclassification, and that can if you use it for the cancer detection and those kind of things, it can be sometimes dangerous if it misdiagnosed. And also that means AI requires obviously lots of data, otherwise it can overlearn or underlearn kind of things. Yeah, so that means that is one challenge. Then real-time implementation is another challenge. But the most important challenge is the convincing the doctors, because some of the the doctors still don't accept the AI or any automated methods. They still try to use the traditional way. So that means there are challenges in this space. But now we can see that this advancement of generative AI space and all, now you can see that there's lots of chatbots can be developed for remote health monitoring and so on. So yeah, with that I conclude my talk, and yeah, these are the references, and yeah, thank you.
Participants, any questions? Any questions from the participants? Many participants are busy with their packing bags.
No problem.
Sir, I think. Sir, yes, you can chart you can text question also. I would like to conclude the session. Sir, from my bottom of my heart, I would like to thank you, sir, in spite of your busy schedules, accepting our invitation to give a guest lecture, expert talk in this in our FDP, AI, artificial intelligence in healthcare and medical technology. Thank you very much, sir.
Yeah, thank you.
Sir also known to us, already given one session. Previously, 2 years back, you have also given one session, sir. And many of our papers also you reviewed, sir. Thank you very much, sir, for your contribution in enlightening us with your great knowledge. Thank you, sir. Have a good day, sir. Thank you.
Okay, yeah, thank you. Thanks.
Thank you very much, sir. Right.
Okay, yeah, bye.